Okay, probability. You guys already know how to do it. We've done it for 2 years together. Right. So just very quickly, there's an example. Okay, let's just go with the basic. Let's say you have a bag and it has marbles in it, right? So 5 are yellow. Yep. You're not going to have to do too much of this. Simple stuff. 6 are blue. 4 are white. What is the probability that you pull a yellow? Yeah. So we have 5 yellows out of 15 total. 1 out of 3, right? Okay, so you're good there. So what I want you to see here is that it's the part out of the total. Okay. All right, we're going to step it up a little bit beyond that today because I know you know how to do those. Okay, let's say you have a circuit board and it has 20 chips, okay, 4 of which are defective. If 3 chips are selected, what is the probability that 3 taste bad? No, I don't eat computer chips for lunch. Sorry. Yeah, thanks for that. Okay, remember we have the part out of the total, right? This is just a probability problem. But how do we figure out? We're picking 3 chips that are defective. That's the part, correct? But what part of the 20 is that? We have to use a combination or a permutation here. Right. Yep. Well, here on top, how many are defective? And we're choosing 3, so it's 4, 3. Okay, what's the bottom? What's the total? 20 and? You're only choosing 3. I almost did. Yep. Now you can do 4 NCR3 divided by 20 NCR3.
.003508771 9.
Yep.
got it.
0.0 what?
00350877.
Okay. 3 decimals is plenty. You headed to AP Stats. That's all they're going to ask you for. Did I round it properly? No, I didn't. AP Math, you can truncate or round, so I can just erase the rest. It's kind of nice, isn't it? You don't have to round properly for some reason. Yeah. Not that that matters to you seniors, but just FYI. Okay. All right, let's move on. Okay, do you know what odds are? What's the probability of winning the game? So what are they? Basically. But what's the probability of getting heads or tails? 1 out of 2. Okay. So what you see with odds is okay. Odds are just a touch different because it doesn't consider the total. Okay. Probability considered the success. This would be success, right? Over the total. Odds are just success over failure, right? So if you have a coin toss, what are the odds you get a head? Yeah, 1, 2. What's the probability of success? Yep. What's the probability of failure? 1/2. So you end up with 1 to 1, right? There's a chance, one chance it could be successful, one chance it can fail, right? All right, let's see here. Let's say there are 6 blue and 4 red chips in a bag. We'll just go basic. Let's talk about chips. It's making me hungry. Huh. Makes sense. Okay, so what is the probability of drawing a blue chip? Six out of 10, okay, which is 3 out of 5. The probability of a red. Yep, so easy it's boring, right? What are the odds of drawing a blue chip? Yeah. Oop. Success over failure. So 6 over 10 is our success. We're drawing a blue. 4 over 10 is our failure. We're drawing a red, right? And if you do your fraction division, copy dot flip, you get 6 over 4 or 3 to 2. Odds are not expressed in decimals. They need to be fractions. Okay. Odds need to be in fractions. Probability you can express as a decimal because it makes sense. But in odds, you're comparing two items. You need to have both items there. So I need to have the 3 to 2, not just a 1.5. Okay. All right, let me show you a permutation combination with odds. And then we'll get on the homework and we'll be good to go. All right. Let's say there are 6 college scholarships. And some of you are going through this right now, correct? Let's say we have 12 males, 16 females that qualify. Yeah, pretty much. We're going to choose, the recipient is chosen at random. What are the odds three male and 3 females are chosen? Okay, so we have to use some reasoning here. We have to actually think through this one. We know that what is, okay, odds are success over failure, right? So if we're thinking through this, what is a success? Yeah. How are we going to figure that number out then? If I have 16 females and I'm choosing 3, and 12 males and I'm choosing 3, how would I figure out how many possible successes there are? Think we are choosing 3 out of 12. What are we going to use? Think yesterday. Combination or a permutation? Which one? Yeah, so we have a combination of 12 people chosen 3 at a time with 16 chosen 3 at a time. Okay, that's our success. It's not just 3 out of 12. Okay, it's not just 3 out of 12. It's a little bit more complicated than that. All right, how many total possible groups are there? Right, there are a total of 6 choices to make. How many total people are there? 28. So we have 28 people and we're choosing how many? 6. That's our total. Okay. This would be probability, actually. So let me change this would give us probability. Okay. Anybody have that number? Higher than I thought it would be. No faith. I have plenty of faith, just not in people. No, we're using combinations because it doesn't, order doesn't matter. Yeah. That'll be the same number. Okay, now odds. And I went the different track here than I should have, but what's the probability of success here? We already have that number, correct? Yeah, we've already figured it out. So we can put the fraction in there. What's the probability of failure? How many would be chosen? It's a really nasty problem if you just try to figure it out with the straight numbers. Okay. What you have, though, both the success and the failure have to add up to 1, right? 100%? Because one of them has to happen. So what you can do is you have your success. The failure is just 1 minus that. And it gives you that odds or the probability of failure. Okay. So probability of success is, and then probability of is that top number. Probability of failure is 1 minus that number. You want to make it easy on yourself. So this is going to come out to approximately 1/2, right? So the odds of success are 1 for every 2 failures. So you'd have a success and 2 failures, success and 2 failures. That's what odds mean. It's not 1 out of 2 tries. It's 1 success, then 2 failures, or some mix of the 3. Okay. So the big thing here, I know you can do probability, very straightforward, but using combinations and permutations within it, you really have to think through these. Okay. There are 6 examples in your book. I went through 4 of them, and I just skimmed really on those 4. So if you need to use your book, it's a good resource on this one. We're in 13.3. I skipped 13.2. And that's what we're going to be working on.